Good morning, students. JNDK Kakinada R23 Regulation, Engineering Physics, Unit number 3, Dielectrics. Now, I want to explain the ionic polarization. Generally, the ionic polarization will be observed in ionic solids. So, let me take an ionic solid NaCl. The ionic form of NaCl is Na plus and Cl minus. Let us suppose that capital M is the mass of Na plus ion and small m is the mass of Cl minus ion. If we apply some electric field intensity E on such type of NaCl crystal, then what happens? The ions of Na plus and Cl minus will gets displaced. The Na plus ion gets displacement of x1 units and Cl minus ion gets displaced of x2 units. That means from the center, Na plus displaced x1 units and Cl minus displaced x2 units. Totally, the total displacement of Na plus and Cl minus ions while we are applying electric field intensity E is x is equals to x1 plus x2. After displacement, the ions trying to get its original position because of the restoring force. What is the restoring force of Na plus ion to get its original position is F is equal to K1 x1. What is the restoring force of Cl minus ion to restore its original position is F is equal to K2 x2. See, from this x1 is equal to F by K1 and x2 is equal to F by K2. Here K1, K2 are called to be as the restoring constants. K1 is the restoring constant of Na plus and K2 is the restoring constant of Cl minus. From this K1 is equal to capital M omega naught square and K2 is equal to small m omega naught square. Here omega naught is the velocity. But the total displacement here we know x is equal to x1 plus x2 and substitute the values of x1 and x2 in this formula. X is equal to, we know, F by K1 means F by m omega naught square plus F by K2, that means F by K2 means small m omega naught square. X is equal to, this one is x1 term and this one is x2 term. X is equal to x1 plus x2. X is equal to x1 means capital F by K1. X2 means capital F by K2. That means x is equal to F by capital M omega naught square plus F by small m omega naught square. Small m F by omega naught square ni common tiste x is equal to F by omega naught square into 1 by capital M plus 1 by small m. So this is the displacement of the total displacement of Na plus ion and Cl minus ion. We know if we get the displacement of the ions, we can calculate the dipole moment. So the ionic dipole moment here is mu I is equal to charge into displacement. Charge E into the displacement here is x. X is the total displacement. So the dipole moment, ionic dipole moment is mu I is equal to E into x. So E, mu I is equal to E into, this is the term x, F by omega naught square into 1 by capital M plus 1 by small m. And we know that capital F is equal to force. Here is small e into capital E. Charge into applied electric field intensity E. So mu I is equal to E into E by omega naught square into 1 by capital M plus 1 by small m. So mu I is equal to E into E square E by omega naught square into 1 by capital M plus 1 by small m. This is the dipole moment. If we calculated the dipole moment, we can calculate ionic polarization. So ionic polarization is equal to dipole moment per unit volume. So 1 by V into mu I. 1 by V can be written as capital N. Capital N into mu I. So Pi is equal to capital N into, already we get the value of mu I. E square E by omega naught square into 1 by capital M plus 1 by small m. This is the ionic polarization. If you know the ionic polarization, we can calculate the polarizability. Polarizability alpha I is equals to polarization per applied electric field intensity E. So Pi by E, that means this is the value of Pi divided by E. We can get Ne square by omega naught square into 1 by capital M plus 1 by small m. So in order to get the ionic polarizability, we need to calculate ionic polarization. In order to get the polarization, we need to get dipole moment. In order to get the dipole moment, we need to calculate the value of displacement. So first of all, we calculated the displacement of ions, Na plus and Cl, the total displacement of ions. And from that, we calculated the value of dipole moment. And from that, we calculated the value for polarization and finally polarizability. Thank you.